Hi guys, welcome to Eli's Academic, and this is your online self-learning portal. For those who haven't subscribed this channel, so make sure you subscribe the channel and click the bell buttons for more videos. In this lesson, I will show you how to construct a tangent and normal equation based on the given curve and the given value of x. Take a look at this example. Determine the tangent and normal equation of the curve, which is hx equal to x cubed minus 1 at the point x equal to minus 1. Alright, alright. Before we construct a tangent and normal equation, let me show you how to illustrate the tangent and normal line on the curve. Let me sketch the HS curve. So first you need to draw that the xy plane. Right, so this is based on the given function of hx. So this is x cubed minus 1. So the curve will be look like this. Right, so now this is your hx, this is your x, and this is the function of x, which is x power of 3 minus 1. All right, now we're going to determine the tangent equation at the point x equal to minus 1. So as well, that normal equation will be fall on the same value, which is x minus 1. Now I'm going to illustrate that the tangent line and the normal line on that curve at the point when x equal to minus 1. So, and let's now determine that the tangent line and the normal line on that given curve at the point when x equal to minus 1. So we can determine that point first. So the x is minus 1. Say this is your x, which is minus 1. So if you draw the dashed line point, so we can draw a straight line which is touch at the point where x equal to minus 1. So this is we call a tangent line, right? Call your tangent line. All right, now, so in order to draw a normal line, so you know that the normal line is perpendicular to the tangent line at the same point which x equal to minus 1. So that will be crossing perpendicular to the tangent line. All right, so this is will be 90 degrees. All right, so now we can say that this is normal line. All right, so as a first step, now in order to construct a tangent and normal equation, first we need to determine the corresponding value of hx when the x is minus 1. So when the x is minus 1, the hx value will be, so you just plug that my x is equal to minus 1 into this the main function, so you get is minus 1 power of 3 take 1, so this will be minus 2. So we know the coordinates. Now we know the coordinates when the x is minus 1. So the y is will be minus 2. So this is a coordinate where the tangent and normal equation pass through. All right, as a first steps, we write that equation of tangent function. So y minus y1 equal to m1 in bracket x minus x1. So this is your equation of tangent. As we know that m1 is the gradient of the tangent function. Alright, now we're going to determine the gradient of the hx function at the point where x equal to minus 1. So we find that the first order derivative of the hx, so which is h frame x equal to 3x square. So when the x is minus 1, so we get the gradient is 3. Alright, now the gradient at the point when x equal to minus 1 is 3. So this also can be initialized as m1. In order to determine the gradient of the normal line, so we have to know that the formula m1 times m2, which is equal to minus 1. So this is, you need to remember in order to find that the gradient which is in the perpendicular. Alright, as we know now, the m1 is 3. So m1 is 3. So m2 is we're going to determine. So now the m2 is minus 1 over third. Let me just move on the next steps. Let's we move on the next step. So first we need to determine that gradient of, we're going to determine that the equation of the tangent, and we know the equation of tangent, we need to know that the coordinates. So just initialize this coordinate with, this is as x1 and this is your y1. Color y minus y1 equal to m1 in the bracket x minus x1. So now y minus y1, you can sub with that minus 2 over there. So in the bracket minus 2. And m1, we know that just now we got a 3. So we just plug with the 3 over here. And then x minus x1, we know that the x1 is minus 1. So bracket x1 and we and we and we close bracket there. So we simplify it. You get y plus 2 and this is 3x, okay, in the bracket 3x plus 1. So you just open bracket, so 3x plus 3, this is y plus 2, and you get y equal to 3x plus 1. So this is your equation of tangent. Next step is you're going to determine that equation of normal. So again, we rewrite the function y minus y1 equal to m2. So now we need to change that the gradient to that m2. So and the x component is x minus x1. So we do the same things as how we did for the tangent equation. So y minus y1, we know that is minus 2. And m2, we know that that is minus 1 over third. And the x minus x1 is minus 1. Alright, we just simplify it now. So this is y plus 2 and this is will be minus 1 over third and bracket. So this is x plus 1. Alright, now you just open bracket. So let me continue here. So y plus 2 equal to 1 over third x and minus 1 over third. And now we bring the 2 to other side. So y equal to minus 1 over third x, and minus 1 over third minus 2, you get 7 over third. Alright, now this is your equation of normal function. That here is the equation of the tangent, and this is your equation of the normal. This is equation of the normal. So you can give the general conclusions. Okay, so we got some space here, so we can write the general conclusions. So you can give the general conclusions. So we just give some general conclusions here. We got some space over here. So therefore, equation of tangent is, so y equal to 3x plus 1, where else, meanwhile, equation of normal is y equal to minus 1 over third x minus 7 over third. So you can give that final answer here. All right. So this is how we need to determine that tangent and normal equation based on that given curve and the given point. Thank you guys. I hope you like this video, and I will see you in the next lesson.